Hi, this is a presentation of how to configure EIGRP for ipv6. And there are so many similarities with EIGRP when we are working with ipv6 if we compare it to ipv4. And that is because, of course, as I told you earlier, that EIGRP is a modular-based protocol, which means we just switch modules. So now we switch over to ipv6. And it uses the same tables. It has the neighbor table, the topology table, and the routing table. So if we compare them, they are basically the same. Of course, we now have the ipv6 routes and prefix, which is the subnet mask in ipv6 that is advertised. It's a distance vector. It uses the dual. The metric are the same. They both use the reliable transport protocol. The updates are sent incremental, partial, and bounded. And it uses the hello packets to send the neighbors, sent to their neighbors. And they use source and destination addresses that when they send updates, both of them uses a multicast address, a specified one for ipv4 and for ipv6. The only little different here is the authentication. In ipv6 we have to use the MD5 algorithm for that. We can also use plain text authentication in ipv4. And the router ID is for both these two a 32-bit ID. Yeah, when we have ipv6, we have, of course, the ipv6 address, but we also use something called a link local address, which is just a address that is significant on a local link, and that makes some of the EIGRP easier to set up, well, not to set up, but to more efficient to work on. So it uses the link local address, for instance, to perform adjacency with its neighbors. So what we do here is that, of course, we just implement everything with the ipv6 addresses. We use the link local addresses, so that's why we need to configure them. It makes it easier if we do. We have already seen that, for instance, when we set up the default gateway also. If we just use the link local address, then we don't have to worry about the long ipv6 address. So here we need, of course, to have, well, we don't need that, but what we do here is to set up the link local addresses on all our interfaces, and it can be the same. Here we have the same link local address on my two serial links and the G interface, the gigabit Ethernet interface. So we can do a show interface ipv6 interface brief, and we will see that our link local address is the same. So how do we do it? Well, first of all, we need to implement or set up that we want to use unicast routing for ipv6. We always have to do that. And then we say ipv6 router EIGRP, and then again the autonomous system. It could be a number, whatever. In this case here, it's set up to be 2. And then we give it an ID. I don't think it's actually needed, but here, since it cannot calculate it by itself, it's best practice to set up a router ID. And then that's it. A no shutdown command on the router ID are required for the router to perform neighbor adjacencies. So it's needed. So, and then we don't do the network command, same thing as in OSPF. We then go to the different interfaces and say, I want to use EIGRP on that interface. So go to interface G00, say ipv6 EIGRP and the number 2 for the autonomous system, and then that's it. And then do it on all of my interfaces. So again here, I implement my EIGRP on the interfaces, not by using the network command when I'm using ipv6. Then I can see my neighbors, and then you can see here my neighbors are then showed by the link local addresses that I've set up. But otherwise, it's the same as the output that it will get in ipv4. As I said, the metric is the same. So when you look at the show ipv6 protocols, then you will see the autonomous system number, you will see how the metric is calculated, you will see the router ID and the administrative distance and which interfaces that I'm running on. So show ipv6 route will also show us the EIGRP entries by a D in front of them. Yeah, and that's it. That's how to implement